Let's talk about ray diagrams. So the purpose of drawing ray diagrams is basically to figure out how the rays of light would move through a medium. And in our case, that's going to be lenses and mirrors in order to produce an image. So we have 3 rules of refraction for a double convex lens. So that's convex lens. And double convex just means that it's convex on both sides. So our first rule is an incident ray traveling parallel. So I ray going parallel to the principal axis will refract through the lens and travel through the focal point on the opposite side. So what that is saying is if I have a lens, that is a horrible lens, ignore that, okay. If I have a lens, and here's kind of the center, and I have an object on this side, this is object O, and it has a ray traveling parallel to this axis here. It will come out at an angle such that it will travel through the focal point on the opposite side of the lens. So that means that this right here has to be our focal point. And on the same distance on the other side is another focal point. And our second rule of thumb is that a ray traveling through the focal point, that's supposed to be directly through it, will come out parallel. And then a ray passing through the center of the lens will continue in the same direction. So we have one going through the focal point on this side coming out parallel, one coming in parallel out through the focal point. Now we have one coming through the center. And where those 3 lines converge is where our image will appear. So next let's talk about a double concave system. And that means a lens that would look like this. So here's our center. So we have a few different scenarios in this case. The first is where we have we need to draw our focal points here. So this is twice the distance of the focal point. Here's the focal point. Here's a focal point on the other side, and twice the distance. So if I have an object over here, outside of the second focal point, the image will have to occur inside the first focal point. And the reasoning for that is that we have to draw our ray diagrams with a similar method. So in this case, we go from the object parallel, and then the line that this ray follows as it leaves the mirror goes through the focal point. So that means that it goes through right here. But how do I find the distance that this image is from the focal point? We find that distance by drawing another ray from the top of the object through the center of the lens. well, that should be from the top through the center. So where those two lines meet is where our image occurs. And this image is a virtual image. And that is much smaller than the actual object, and it's always formed inside the focal length of the lens. Even if we moved our object over between the second focal point and the first focal point, we could draw the same lines. And then our line through the center would go like that, and we would end up moving our image over just a little bit. And concave and convex mirrors follow this same idea, that you have to draw a line parallel from the tip of the object and then connect it through the focal point, and then through the focal point and out parallel. So here, let me give you one example, because what I just said probably doesn't make sense unless you're looking at a picture. So here is the face of our mirror. The center line, we have a focal point F, and our object over here. Where would our image occur? Well, we need to draw a ray out from the object parallel to this center line, and then it reflects down through the focal point, and then through the focal point and out parallel. Where those cross are where the image occurs. And then for mirrors, there's this extra little location labeled C in a lot of diagrams, and C stands for center of curvature. And this center of curvature just means that if I were to make this mirror a full sphere, the center would occur at that location C. So this is just a very brief overview of ray diagrams for some lenses and mirrors. You follow this process of drawing rays through focal points and out parallel, and vice versa for all of the different types of lenses and mirrors in order to find the image location.